Okay, so we've got 5 factorial on the top, and then 5 minus 2. Do you get what happened there? Some of you are still talking. Please stop that. 5 minus the 2 gives me 3 factorial, and that's what's on the bottom. It's not that complicated. If you understand that the factorial thing means 5 times 4 times 3 times 2 times 1, and the 3 factorial means 3 times 2 times 1, then watch what happens. It's really cool. This is a multiply, so it can cancel this other multiply on the bottom, and the answer is just 5 times 4, which is 20. Okay, let's do another one. 8p6. First of all, what goes on top? Say it right. 8 factorial. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It's a bit of a pain to write them all out, but do it. Won't take you that long. And then divide it by not 6 factorial. That's the common mistake. 8 minus 6, which is 2 factorial, which is really just 2 times 1. Right? And the 2 times 1 can cancel the 2 times 1, and that is a huge number, and that's your answer. That would have been the answer to a question like this. I have 8 people. I'm choosing out sets of 6. And if the order matters, the order matters, and that reminds me to use a P. If the order matters, there's a ton of answers. How many? 8 times 7 times 6 times 4 times 3. All right. And I want you to get the connection to this. Remember the blanks method? If this had been, we are going to take, there's 8 kids, and I'm going to put them up in like a lineup of 6, okay? Because one of them is the one that stole the cheese. And so they're in a lineup now, and somebody has an eyewitness, and they're going to stand behind the glass, and they're going to look and see which of these kids did it. All right, so I have a lineup of 6. How many choices do I have for this spot? There's 8 kids, and I'm choosing out 6 to be in the lineup, so there's 8. And how many for this spot? Do you get where I'm going here? And that's the right answer. Look at that. No, 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 no. See? Look. Focus, focus. So the answer we got is the same as if we had done it with the blanks. But a reminder, the blanks are more powerful because you can also make adjustments like this. But we're going to line these all up. But there's one kid who's really shy, and he's not going to want to walk past all the other people, so I'm going to put him there. I'm going to for sure put that one kid on the end there just to make it all work better. So then there's only one choice for that spot. And I can make adjustments like that if I use the blanks method. I can't factor that in if I'm going to use a permutation with just a P. All right, so the blanks are better than the permutations. All right, because it can be more flexible. So try this one. 7p4. Use your big brain. Figure out the answer. You do not use a calculator. Now, you might be thinking, but wouldn't I just be able to use a calculator on the test? No, because we're going to use a variable in this. If you don't know how to do it without a calculator, you won't be able to do it. So it's what on top? How do you say it right? 7 factorial. And 3 factorial on the bottom. Cancel, cancel. It's 7 times 6 times 5 times 4. And one way to do this sometimes, 7 times 6 is 42. 5 times 4 is 20. So it's 42 times 20. You know what I did there? Just a way to do it a little faster. 42 times 20. Well, that's like 42 times 2, and then you just add a 0. Can you do that in your head? Sure. What's 42 times 2? 84, add a 0. 840. Yes. You can use the blanks method, but here's where the blanks method would fail you. A, P, R. What's the formula? Well, I know the formula. It's some factorial thing over some other factorial thing, and it's not that hard. What would it be? A factorial over A minus R factorial. See? Now I can do it even if I don't even know what the numbers are. Okay. Now I have to show you how to do a C. And it's very, very similar, but it's different than the P. All right. So let's say I did, let's be realistic. There's about 32 of you in here. Choosing out groups of, let's say I can fit 25 in this like small, one of those little short buses, okay? And I'm going to have you 25 kids on the short bus. So my question is, if I'm going to have 32 C25, there's something, I don't even need to know the answer because it's going to be a really big number, but there's something I'd put on top, something on the bottom, and if this was a P, you would have said, what goes on top? 32, and then what's 32 minus 25? What's that? 7. So it's very similar to that. But C, there's one more of these. Do you get what I said there? C, there's another one of those. There's an extra 25 factorial on the bottom. Good question. Why is there an extra 25 factorial on the bottom? Because with a C, order doesn't matter. Now, I want you to think about why that affects the answer. If I had these 4 boxes of Kleenex here, and I line them up in this way. Now, if I'm asking about the order that I could put them in, then that implies the order matters, right? If I just said how many different ways can I put these up here, that implies the order matters, and I got to use a P. But what if the question is about C, as in the order doesn't matter? Then I'm taking these 4 back, and I'm going to say, if I was going to take these 4 boxes of Kleenex that I have out here, it's obviously a 4, and I just said it was going to be a C, as in the order didn't matter. 4C2. I'm going to choose 2 Kleenex boxes at a time. Do you get if I take these 2? There, I've chosen them. Do you get that I don't need to rearrange them because the order doesn't matter? I got the one that's kind of gray and the one that's kind of teal. Okay, I got the gray-teal combo. It doesn't matter if it's teal-gray or gray-teal. See what I mean? So the order doesn't matter. Doesn't that mean I'm going to have less answers because I don't have to rearrange them all the time? Because if I was doing a permutation, I'd say this is one, and then this is one, and I have to constantly rearrange them, right? So there's less answers when it's a C, and so that means when we do the calculation here, it's 4 factorial over 4 minus 2 factorial, but C, there's an extra one of these. When you divide by something, you make the answer smaller. That's what we're doing is putting an extra thing on the bottom. So basically, you're taking your answer and dividing it by more. When you divide it by more, the answer gets smaller. Why should the C answers be smaller? Because you don't have to rearrange them. Okay, so that's why there's an extra number on the bottom in the C calculations. All right, let's just actually finish this one. It would be 4, 3, 2, 1. That's the 4 factorial. 4 minus 2 is 2 factorial, 2 times 1. And there's another 2 factorial, 2 times 1. And just to clarify, we multiply there. So the final answer is, well, the bottom is a 4. That would cancel this 4, wouldn't it? Notice me doing all my canceling first. And then at the end, I just do the multiply. Because now I can do it easy. 3 times 2 is 6. Answer 6. All right. So that was my Kleenex box question. Want to see the 6 combos? That's one combo. Notice I'm not going to have to rearrange them. This is another combo. Okay. Here's the third combo. Then there's this combo for 5, 6. See? There's the 6 combos. What if I had cared about the order mattering? There'd been more, right? In fact, it'd be really simple. I just had to rearrange them, and there'd have been twice as many. So there'd have been the 12 combos. See what I mean? So the C number is simpler because I didn't have to worry about the order mattering. It's like if I ask a group of kids to help me, I say, hey, can 4 of you help me carry something? I don't need to rank you. Like, ooh, you're number 1, you're number 2. I just have to have 4 kids. Doesn't matter what order. Okay, so if I get Bob, Sally, Mick, and Chris, those 4 people are going to come help me. I'm not going to like say rearrange all these orders of how they could help me. It's just simple. I got Bob, Sally, Mick, and Chris, and they're going to help me. Okay. So you've learned how to do it by hand, I hope. Here's your final test on it. 8P7 and 8C7. The answers should be different. Try to figure them out without a calculator. And then this is a trust walk. After you're done doing them by hand, then use your calculator to check and see if you got them right. Let me pause for a second. For you to figure them out by hand, and then you check them with your calculator. If your C answer didn't come out smaller, then something's wrong. Okay, I'm going to pause while you give that a shot. Here's what you should have done. 8 factorial. Quiet, please. Focus. Look this way. Thank you. All right. 8 factorial over 8 minus 7, which is 1 factorial. And yes, there is such a thing as 1 factorial. It's just 1. Done. And then, do I do an extra thing on the P? No. So this is just 8 factorial. Your final answer. I would not make you actually multiply 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 in your head. Oh my gosh, are you kidding? Now I know you could do it. 62,000 and something? No? 40? Okay, whatever. So I'm not expecting you to have done that in your head. This one, 8 factorial over 8 minus 7 is 1 factorial with an extra 7 factorial, which is a big deal because then that one cancels a lot. I'll show you. 8, 7, 6, 5, 4, dot, dot, dot. Math teachers are naturally lazy. We do that. 7, 6, 5, dot, dot, dot. And then that's going to cancel with that. So the answer to the other one's just 8. Why should it be so much smaller? It's just 8? Yeah. Because the order doesn't matter. So if we have 8 boxes of Kleenex and we pull out sets of 7, there isn't going to be a lot of sets of 7. There's going to be 8 sets of 7 to be exact. But if the order of those 7 things were to matter, I pull out 7 Kleenex boxes and have to rearrange all the different permutations of that, that's going to be a big answer. All right. So a typical question you'd be asked in a minute is, some of them are so simple that they freak people out. So I'm going to give you a little practice on one of the kind of questions. One of the kind of questions is like this. Let's say that you get up in the morning and you have 5 pairs of pants that you can pick from, 3 shirts, and this is what's clean, right? And then you have 4 pairs of underwear, and you know, the ones with the little smiley faces on them, and then the ones with polka dots, and then the simple black ones. Anyway, so my point is, do you get that unless it's a very unusual day, you're only going to be wearing 1 pair of pants? Hopefully only 1 pair of underwear, unless you like to be really safe. 1 shirt. Then how many different outfits can you have? You should think of this like choices. And what do you do with choices? Do you add them? No, don't ever add. You multiply. You multiply choices. How many choices do you have for the pants? Times how many choices for the shirts? Times how many choices for the underwear? And you multiply them all out. 4 times 3 is 12. 12 times 5 is 50, 60. 60. There's 60 different combos you could wear. Notice, did we ever talk about what order you were going to put them on in? Because, granted, you probably... All right. Imagine for a moment that there are 32 kids in here, and I'm going to choose out a president and a vice president. Did I just set it up right? No. Why? Because order matters. Therefore, it should be a P. Okay, good. All right, next. We are throwing in a little bit of review of probability of this stuff. A, B, C. Do you remember these? Okay, let's say I said it's banana, apple, and chimpanzee, because of course that makes sense. Banana, apple, and chimp. Oh, come on, go with the more unusual. So, how many of you have a chimpanzee? Okay, I got 6. I knew I'd have some. All right, so that means there's a total of 6 in here who have a chimpanzee at home. Now, if I say that you've got a chimpanzee and you've got a banana, wouldn't it make sense? Because, you know, you feed the chimpanzees the bananas, so it would make sense. There's a fair number of those 6 that have bananas at home. In fact, there'd probably be none that wouldn't have bananas. Do you get what I just did there? But now that I say that there's 6 chimps, some people go, oh, so 6 goes here. Don't do that. You remember that mistake? The 2 together have to add up to 6. Get what I'm saying? So just be careful on that part of the question. All right, so if these together have to add up to 6, then what if they later tell you, oh, there was one person that had an apple and a banana and a chimpanzee. Then there's a 1 here, and then therefore, that has to be a 5. Together, they make 6. All right, so watch out for that. All right, now I've taught you everything that you need to know for both tonight's homework, which is a homework quiz, but there's a separate one. The one I'm talking about that you should be taking right now. You're a special case. You'll talk to me later. I don't know why you took it early, but we'll talk. The one you're supposed to be doing, I'll show you exactly what it looks like here. In class, it's this one that's kind of on the outside. It's not in a folder anywhere. That one. That is the homework quiz I want you to take in class, and you must finish in class right now. If you started it, then you started it. I don't recommend that you started it, but all right. So there you go. Finish that one. That's your quiz that happens in class right now. You have till the end of class to finish it. The other one that's your homework, that one's in the folder for today like normal. The one that's for homework is that one. The one you're taking right now in class, that's this one. Okay, so please take that homework quiz right now. And some people thought, Mr. Server, the Venn diagram is not possible. I tried it and I know it doesn't work. Well, you're doing it wrong. I double checked it. And it's typically a mistake, like I showed you earlier, where people are thinking it means that this spot is 6, but together there's 6. Anyway, all right. Take your time, finish that homework quiz. The homework for tonight is the homework quiz that's buried in the 5-9 folder. Okay, that's all I got for you for today.